think the biggest obstacle that the utility industry faces in terms of implementing drones is that drones are just really hard to fly.
When I was a company commander in the middle point of the Iraq War, our companies were deploying for 7 months and they would be back in the US for 5 months. And in a 5-month period of time, you had to train up your Marines on some very, very complicated tasks. So the easier it is to fly, the easier it is to maintain, those all add up.
Our second generation drones were the first drones that really were autonomous enough to operate in unknown, complex environments. Now, with our third generation of drone, we are fundamentally upgrading both the camera package with custom design navigation cameras and also a compute package by having the NVIDIA Orin and state-of-the-art Qualcomm Snapdragon chips that have 10x the deep learning capability. With increased compute power, we're able to process these cameras at higher resolution, and then we're also able to see in lower light and higher dynamic range scenarios. And so we're going to be able to really fundamentally upgrade what our drones can do.
We were able to build a whole camera from scratch as a custom design. Every single part of it was optimized for its maximum functionality, which is very hard to get with off-the-shelf components. We're able to go to like more than 2x the sensor resolution that we had compared to our previous generation. So what that means is like our sensor resolution is so much better than what we had before that we should be able to detect and avoid like much smaller obstacles with much higher accuracy. So that resulted in what I consider is a best-in-class navigation camera.
One of the things that we're doing is we're supporting IR or thermal subject detection for the very first time, building a lot of these features that enable operators to have a better sense of their surroundings, and that's what situational awareness is all about. Right now, we're enabling the ability to autonomously track vehicles and people from very far away in daytime and at night, primarily talking about doing that on the long wave infrared or the thermal camera. The data collection piece is hard.
One of the big things is that the thermal feed is actually registering a temperature signature, and so we don't have colors, for example, of the clothes that people are wearing, which are typically used by the tracking component. And so we could even use, for example, a detection only approach and per frame detections rather than using a detection plus tracking approach, which is computationally more efficient for higher resolution cameras.
We demonstrated against a variety of different backgrounds that we're able to track subjects very effectively.
Having a really powerful camera and sensor package combined with much more powerful computing allows us to be able to build for years on top of this platform to add more and more AI functionality and make the drone more powerful because we have the foundations of the hardware.
Ultimately, the improved autonomy makes the barrier of entry even easier because it takes the burden off of the user to have to be perfect. At the end of the day, you're not looking to make pilots, you're looking to give your existing frontline personnel the tools that they need and the skills that they need to do their jobs more efficiently and more safely.